Welcome back on the final day of the system design interview mock test on DynamoDB. How would you model a one-to-many relationship in DynamoDB?
All right, good morning everyone. Thank you for asking this question. This is really a good question. In DynamoDB, to model a one-to-many relationship, I would typically use a single table design with a composite key. The primary key would consist of a partition key and a sort key. For instance, if I am modeling a blog application where one author has many posts, the author ID could be the partition key and the post ID could be the sort key. And then I could perform a query operation on the author ID to retrieve all posts by a single author.
Let's focus on table design because this is the first step which must be correct to get the maximum value from DynamoDB. So would you please give me the process of table design?
All right, let me explain you my approach on table design. So let's assume that my table name is blog post, and in that my primary key consideration is composition of partition key and sort key. Let's consider author ID as a partition key and post ID as a sort key, right? Each item row in a blog post table is uniquely identified by a combination of author ID and post ID. The author ID represents the unique identifier for an author and post ID represents the unique identifier for the post made by the author. Okay, so at this point, let me bring one picture, table picture, which will be considered as a sample table for you to understand that how data is organized. Okay, look at this table. In this table, you can see that author ID A1 has 3 posts, P1, P2 and P4, while author ID A2 has 1 post, which is P3. So by now, I explain to you my decision to consider the primary key, which will help me to distribute items across the partition uniformly. Then I also shown you that what kind of table data look like on the basis of my table design decision. Now, the next point which I will focus on querying the data, like what kind of pattern I am sensing in my data, in my application requirement, so that, and does this meeting my requirement, and it is like giving me the optimal performance for those kind of querying with the data or not. Next point I'm going to explain you. Just hold for a moment. I am going to explain that part right now. Okay, so let me try to explain you how querying data will work in our case. To get all the posts, because what is my requirement? To get the all post by particular user, right? So to get all the posts by a single author, you would perform a query operation on the author ID. Am I right? So for example, to retrieve all posts by author A1, your query would specify author ID is equal to A1. This would return the items with author ID A1 and all of the post values that are associated with author ID A1. The DynamoDB query operation find items based on primary key values. You can query any table or secondary index that has a composite primary key, a partition key and a sort key. Let me put one query code, roughly query code link, editorial link here, so that you can refer that link for getting that code which I have written for query. Then let's try to understand how this query is working. So this query would return a list of posts by the author with author ID A1, which is the example I have taken. And the DynamoDB service is optimized for this kind of access pattern, where your query for all the sort key values associated with a particular partition key. This allows for efficient retrieval for all related items. In this case, all posts by a single author without a scan is happening, which is our requirement. Okay, so that's why this is very, very appropriately done. This example is rightly captured the performance without scanning the complete data set, complete database. And that is what we need to achieve. We need to design our table in such a way, our table and primary key in such a way that you can fetch the data without complete scanning. I hope I'm making sense here, and let me know if you have any further query on my analysis or my explanation.
Thank you for such a detailed answer. Moving on, can you explain the difference between the global secondary index GSI and local secondary index LSI in DynamoDB?
Certainly. A global secondary index, which is also called GSI, is an index with a partition and sort key that can be different from those on the table. GSIs can span multiple partitions and are suitable for querying on non-key attributes. A local secondary index, LSI, on the other hand, shares the same partition within the partition, okay? Same partition key as the table, but has a different sort keys. LSIs are scoped to a single partition and are useful for querying data within that partition. Additionally, GSI can be created or deleted after a table is created, but LSIs must be defined at table creation time and cannot be modified afterward. So this is one good difference between LSI and GSI. Please note it that GSI can be created or modified or deleted after the table creation also possible. But on the other side, like LSI case, you have to create your LSI at the time of table creation only, and once it is created, you cannot have allowed permission to modify it after that. So this is what one significant difference between LSI and GSI. Okay, so this is the briefly I can say.
So, can you explain to me why LSI can't be modified once a table of DynamoDB is created?
Okay, let me explain to you the reason behind not allowing modification of the LSI after table creation. These are few possible reasons, and majorly like it based on the performance and the optimization and like cost optimization performance. These are the factors which is the output. But what are the 4 key criteria on which LSI is not allowed to modify later once table is created? What I can see here is that first reason is immutable schema. Okay, the second is data synchronization requirement, and the third is partitioning strategy, and 4 is resource allocation. So let me explain you the immutable schema. Schema, even though it is a NoSQL, still at certain level you have to make yourself immutable, at least at the partition level, so that inside one partition it is sanitized well with the regular schema change, which will impact lots of on other factor like data synchronization, then moving the data from one schema to other schema, which requires lots of data backfilling and those things, right? So that's why these are not, at least not recommendable, and that's why LSI architect of DynamoDB has decided to do these kind of attributes on LSI. Another thing is data synchronization. Of course, if you change the schema, it requires a repopulation of your data into the existing data, and which is definitely going to be a big hurdle for you. Same way partitioning strategy, and then resource allocation, which is decided once you decide the primary key concept for your table. So these all are primary reason. In detail, if I go in detail, maybe it will take lots of time. So I'm just wrapping here briefly. And so in general, I would say that to maintain the performance and scalability guarantees that DynamoDB provides, the schema design is fixed once a table is created. If you need to change an index, you would typically have to create a new table with the desired indexes and migrate your data, old table data, to the new table. Now let's discuss some scenario where you anticipate the need to change the indexing strategy after table creation. What you do in that case, DynamoDB offers global secondary index GSI, which can be added or deleted after a table has been created. So GSI has this advantage, please note that, and that's why GSI provide more flexibility but come with their own consideration regarding performance and resource usage. So I hope that I'm making sense to explaining you why LSI is not modified after the table. Thank you for completing this video, and I hope that you definitely have learned something which will help you in your system design interview. Hope to see you in next video with new concept and skills needed for the system design interview. By then, keep learning, keep improving, and keep sharing your knowledge.